All right, section 3.3 is proofs with parallel lines. So if we say using properties of parallel lines, so if two lines are cut by a transversal, so I want you to think I'm going to say that before every single one. So if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. If the alternate interior angles are congruent, then the lines are parallel. The alternate exterior angles are congruent, then the lines are parallel. And with consecutive interior angles, if they are supplementary, then the lines are parallel. Remember, the converse is switching the P and the Q. So if we had if P then Q, we have if Q then P. So that was, again, we're taking the converse from the ones that we learned in section 3.2. All right, so again, let's go ahead and do a couple of these here real quick for you. So the first one here says, find the value of x that makes m parallel to n. So if you look at what we've got here, we've got 72 degrees right here. All right, and we know that we have 4 times x plus 5 there. Well, that's not going to really tell us much, but we do know that we have an F angle here. So we have at the top there, and we know that this one here would also be 72. So let me go ahead and write it there, because again, by an F angle there. So I'll go ahead and show you the F there. We know that that one and that one are also equal to 72. And remember, those two now form a linear pair, right? And a linear pair is equal to 180. So we're able to say then that 4 times x plus 5 plus 72 is equal to 180. So now on this one here, again, you can distribute that 4 through the parentheses afterwards. Well, first let's subtract 72, right? So now 4 times x plus 5 is equal to 108. Now, like I said, we could distribute that 4 through the parentheses, but if you notice here, 108 is actually divisible by 4. So if I divided both sides by 4 here, okay, then I would have just x plus 5 on this side, right? Because those two would go away. And then 108 divided by 4 would give you 27. So when you subtract 5, we'll get that x is equal to 22. Okay. Now, I went ahead and just did the proof here for you because, again, there's no proof on the homework. But again, I still think you should be able to see kind of the proof and, maybe sometime try to do it on your own. So the first one, again, we were given, all right? So then I look at it and I saw that just kind of like I just did above by the linear pair there, I can say that angle 2 and angle 3 are supplementary angles by the linear pair postulate. Okay? And then remember, I can then state that since they are supplementary, I can say that their measures equal 180 degrees, and I can say that their measures equal 180 degrees. Again, the key word is are there. So I told you if I see the word are or is, a lot of times it'll be by definition of supplementary angles, which I just showed you. All right. And then again, I'm kind of showing you here, if we have the transitive property, so if A is equal to B and B is equal to C, then I can state that A is equal to C, which is what I did in 4, again, by the transitive property. And then if you notice, again, since I have the measure of angle 2 on both sides, I can subtract that away and all I get is the measure of angle 1 is equal to the measure of angle 3. Now, once that I have that the measure of angle 1 is equal to the measure of angle 3, remember, if I know their measures are the same, then I can say that they're congruent. Since I can say that they're congruent, so I can say the measure of angle 1 is congruent to, well, first of all, measure of angle 1 is equal to the measure of angle 3. And then I can state, since their measures are the same, I can state that they're congruent by definition of congruent angles. And again, the last thing is always what we're trying to prove. So if we know that P is parallel to Q, and again, if we look at it here, again, I have my F angle here, and I have the bottom of the big part of the F, the bottom of the little part of the F. So those are corresponding angles. And if I can state again above, notice how I used a previously proven theorem to prove this theorem, which is what we have to kind of do here. So on that one, if corresponding angles are congruent, then the lines are parallel. So I just wanted to show you that real quick. Like I said, because eventually you'll find out that proofs are important. But again, we're just giving you a couple at a time. So example 3, decide whether there is enough information to prove that M is parallel to N. If so, state the theorem that you would use. So on this one here, if you notice, they have the this angle marked and this angle marked. So on that one there, again, what does that kind of show? Again, we can have sideways F's here. Right. So if we look there, we do have the top of the F and the top of the F. So we can say on this one it's yes. And our reason is the corresponding angles converse. On B, is there enough information? Let's see here. Well, I know that since these ones are marked, I know they're vertical angles. But I would need something to show on this one here, either alternate interior angles, alternate exterior angles, but line N doesn't have anything marked on it. So there's really not enough information here, so I would say no on that one. Okay, and then finally, theorem 3.9 is the transitive property of parallel lines, which states if two lines are parallel to the same line, then they are parallel to each other. So if P is parallel to Q and Q is parallel to R, if P is parallel to Q and Q is parallel to R, then I can state that P is parallel to R. So that transitive property, we've seen it here a lot, and with our last example here. So on the last example, if each parking space in a lot is divided by two parallel lines and share a common line with the next adjacent space, explain why the left line in space 2, so the left line would be this one right here, and they want us to explain why it is parallel to the right line in space 8. All right. So they've told us that angle 1 here, this one right here, and let's go ahead and just name it. Let's name it A. And we know it's parallel to B because they told us they're all parallel, which is parallel to C, which is parallel to D, which is parallel to E, which is parallel to F, which is parallel to G, which is parallel to H. So again, let's think about it here again. If A is parallel to B, and B is parallel to C, then I could say A is parallel to C, right? I can keep doing that for so on here. So how can I explain that they are? And again, it's just by the transitive property. Of parallel lines. Okay, in this case, we're just using it a bunch of times because again, we could then state that since A is parallel to C, we can say that C is parallel to D and E, then C is parallel to E, so A is parallel to E, etc., etc. So it's a pretty simple thought process there, and a quick and easy lesson here, people. Thank you.